In the next 2 lectures, we are going to analyze actors and try to get the most successful or most active actors of all times. And given the more complex structure in the cast column, where we have all actors of a movie in one string separated by a pipe, first of all, we have to process and reorganize the data. And that's exactly what we're going to do in this lecture. And I would say that this lecture is the most complex and most demanding lecture in the first case study. So take your time and keep in mind that you can further analyze and play around with the code here by just downloading the Jupyter Notebook. Here in DF, each and every row is one movie, and we can clearly identify movies by the unique movie ID. And first of all, it could make sense to have the ID as the index of our data frame. So we set ID as the index. Now the plan is to extract the actors from the cast column and create an actor data frame where each and every row stands for an actor who acted in one specific movie. For instance, we have one row with Tom Hanks in Forrest Gump, one row for Tom Hanks in Saving Private Ryan, one row for Bruce Willis in Die Hard, one row for Bruce Willis in Pulp Fiction, and so on. And finally, we should end up with an actors data frame that has a lot more rows than DF. So we have seen before that in DF, we have 44,000 rows, and each row is one movie. And let's assume that the average number of actors in a movie is 10. Then we would end up with an actors data frame that has 450 or 440,000 rows. So that's the plan for this lecture. And first of all, let's again start with the cast column. And each and every element in the cast column is a string containing several actors separated by a pipe. And we can actually split those strings here up with actually some very basic Python string methods. And we can use string methods also in pandas with the accessor str. So with this, pandas knows that now we want to perform a string operation. And then we can use the special string method split that splits all strings up at a predefined separator. And here we can define that this is the pipe symbol here. So let's run the cell and let's have a look. Now, instead of having strings, we have here lists with the actors, Tom Hanks, Tim Allen, and so on for each and every movie. And now there's the additional parameter expand. And by default, it's set to false, but we can also set this to true. And by doing so, we can expand the splitted strings into separated columns. So instead of having here Tom Hanks and Tim Allen, we have now Tom Hanks in the first column, Tim Allen in the second column, and so on. So let's scroll here to the right-hand side. And in the first movie, we have in total 30 actors. And therefore, we have here until column 12 at index position 13 an actor. And then starting with column 13, we have none here for missing value. So there's indeed one movie that has in total 313 actors. And therefore, we have here 313 columns. So that's the structure here. And first of all, let's save the new data frame in the variable actor. So that's our new actor data frame. And actually, the actors are organized in columns, or to say horizontally. And the plan is now to reorganize this to have this organized vertically. So to say, to have for the movie with IDs 862 in total 13 rows, with the first row Tom Hanks, the second row Tim Allen, and so on. And we can actually do this with stack. So let's have a look here what stack does. And it actually stacks the pre-described level from columns to index. So we reorganize the over 300 columns in 2 rows and create a multi-index here in the index. And we create actually an inner index. So let's have a look here. So let's cross the other things out here and let's have a look. And here we have now a panda series with a multi-index, and on the outer index level we have the movie ID, and on the inner index level actually here the column labels, so 0, 1, 2, 3 until over 300. And as values of our panda series we have now the actors Tom Hanks, Tim Allen, and so on. And now let's get rid of the inner index here, so that is not really meaningful. And we can do this with a reset index, and we define that we want to drop the level at position 1. So here we have the level at position 0, then that's the second inner index level. And we have to pass true to the drop parameter also. So now we simply removed the inner index level. And now finally we convert this panda series to data frame with 2 frame. So now let's override our variable actor. And now we can see that here we have a data frame with over 550,000 rows. So on average, each and every movie has more than 10 actors. And then next we should rename here the column label from 0 to actor. So let's re-inspect here. So now each and every row is a combination of a movie and an actor. And now in a final step, it definitely makes sense to add some more information on the movie. So for instance, the title, the revenue, vote average, popularity, and so on. And this is actually a left merge or a VLOOKUP in Excel. So we use here the merge method, and we actually, the left-on data frame is our new actor data frame. And the right data frame is DF with the columns title, revenue, vote average, and popularity. And we want to have a left join or a left merge. And actually we want to merge both data frames on the movie ID, which is the index in both data frames. So we set true to the left index and to the right index parameter. And let's override actors, and let's simply have a look at the final result. So here we have, for instance, the movie with ID 2, and for each and every actor of ID 2 we have 1 row, and we have some more information on the movie. So it's the title, for instance, Ariel, then revenue, vote average, and the popularity. So here we have our final actors data frame. And now in the next lecture, we can start to aggregate the data frame and analyze how successful and how active the actors are. All right, thanks for watching, and see you in the next video. Bye.